Today we will discuss Newton-Raphson method to find approximate solution to the algebraic and transcendental equations. Before going to say the Newton-Raphson method, let us see the intermediate value property. What is that property? If f of x is a continuous function in the closed interval ab and value of the function f of x at the end points, that is at f of a and f of b, are of opposite signs, then the equation f of x is equal to 0 has at least one real root between a and b. Now let us see what is the derivation of Newton-Raphson method. Let x naught be an approximate root of the equation f of x is equal to 0. Let us assume that x1 is equal to x naught plus h with the exact root, where h is very small, either it is positive or negative. As we are saying x naught is an approximate root, obviously if we are adding that h, we are assuming that x1 is equal to x naught plus h is the root. So obviously h must be very small, either it may be positive or negative. As x1 is a root of the given equation f of x is equal to 0, therefore we must have f of x1 is equal to 0. Now let us expand this left hand side by using Taylor series about x1. So we get f of x1 is nothing but x naught plus h, therefore f of x naught plus h is equal to f of x naught plus h into f dash of x naught plus h square upon 2 factorial into f double dash of x naught plus h cube upon 3 factorial into f triple dash of x naught plus so on. Since we know that the quantity h is very small, therefore the second power of h and the higher power of h are negligibly small, so we can neglect them. If we neglect them, so this f of x1 becomes, this expression simply remained with, or we can say that f of x naught plus h into f dash of x naught is approximately equal to f of x1, but the f of x1 is nothing but 0. So we can say that, or we can write this whole equation as f of x naught plus h into f dash of x naught is approximately equal to 0. If this f dash of x naught is not equal to 0, so we can write this equation as h is equal to f of x naught upon f dash of x naught. Let us substitute the value of h in the expression of x1. So we get x1 is equal to x naught minus f of x naught upon f dash of x naught. So in this way we have obtained the first approximation x1 from the initial approximation x naught. Similarly, if we start with this approximation x1, we will get the next approximation, say x2, and the formula for the next approximation x2 becomes x2 is equal to x1 minus f of x1 upon f dash of x1. In general, from the nth approximation we will obtain the n plus 1th approximation to the root by the formula xn plus 1 is equal to xn minus f of xn upon f dash of xn, where the range for n which starts from 0, 1, 2, 3, 4 and so on. That is, if we substitute n is equal to 0 in this equation, we will get x1, that is the first approximation. If we substitute n is equal to 1, we will get the second approximation, that is 1 plus 1 is 2, that is x2 and so on. So this formula is known as Newton-Raphson's iteration formula, or simply Newton-Raphson's formula. Now let us see the steps or the algorithm for the Newton-Raphson method. First of all, we have to rearrange the given equation in the standard form f of x is equal to 0. Once we rearrange this equation, in the step number 2, we have to differentiate this function f of x with respect to x. So we get f dash of x. In the third step, let us choose one suitable initial approximation x naught with the help of the intermediate value property, and at last calculate the values of f and f dash at this initial approximation x naught and substitute in the Newton-Raphson formula to obtain the next successive approximations. These 4 steps we have to continue until the root is obtained to desired accuracy. Now let us consider one example. Find the real root of the equation x cube minus 3x is equal to minus 1 by using Newton-Raphson method. Correct up to 4 decimal places. Solution. Step number 1. The step number 1 is writing the given equation in standard form. If you observe, this given equation is not in standard form. F of x is equal to 0. So we will convert it by taking this right hand side minus 1 to the left hand side. So the standard form becomes f of x is equal to x cube minus 3x plus 1 is equal to 0. Now now the step number 2. Now we are differentiating this f of x with respect to x. The derivative of f of x is f dash of x. Derivative of x cube is 3x square. Derivative of minus 3x is simply minus 3, and the derivative of a constant is 0. Therefore, the simple derivative becomes f dash of x is equal to 3x square minus 3. Now step number 3, our aim is to choose initial approximation by using the intermediate value property. If you observe, it is a polynomial, so obviously it is continuous. So we are able to use the intermediate value property for this particular function. So let us start with substituting the value x is equal to 0. If we substitute x is equal to 0 in this expression, we get f of 0, that is 0 cube is 0, minus 3 into 0 is 0. So 0 minus 0 is 0, plus 1 constant as it is. So f of 0 is 1. It is positive. If you put x is equal to 1 minus 3 into 1, it is 1 minus 3 minus 2 plus 1 is minus 1. If you observe, the values of the function at 0 and 1 are opposite, having opposite sign. One is positive, another is negative. Therefore, by the intermediate value theorem, the given equation f of x is equal to 0 has at least one root between the points 0 and 1. So we may take any number between 0 and 1 as the initial approximation. Now here we are choosing the initial approximation as x naught is equal to 0.5. Now let us calculate the f and f dash at this point x naught f of 0.5. With the help of calculator we will get the value minus 0.375 and f dash of 0.5 is 2.25. To obtain the first approximation to the approximate root, we will substitute n is equal to 0 in the general Newton's formula. If we substitute n is equal to 0, the formula becomes x1 is equal to x naught minus f of x naught upon f dash of x naught. After substituting the corresponding values, we will get the value as 0.333. Similarly, to get the next approximation x2, we have to substitute n is equal to 1 in this expression. So we will get that formula x2 is equal to x1 minus f of x1 upon f dash of x1. We are having already the value of x1. Simply substituting x is equal to x1 in f and f dash, we will get the corresponding values. So we get the next approximation x2 as 0.3472. Similarly, continuing these same steps, we will get the next approximations x3 as 0.3473 and x4 as 0.3473. If you observe these two successive approximations, both are the same and these are correct up to 4 decimal places. So we can say that x is equal to 0.3473 is the required root of given equation and which is correct up to 4 decimal places.